In the previous lectures, we've seen how to crack the WEP encryption in minutes, even if the target network is not busy. Now, in the next lectures, we will talk about cracking WPA and WPA2. First of all, before we start talking about how to crack these encryptions, it is very important to understand that both of them are very similar. The only difference between them is the encryption used to ensure message integrity. WPA uses TKIP and WPA2 uses an encryption called CCMP. In any case, this does not affect the methods that we're going to use to crack WPA and WPA2. Therefore, all of the methods that I'm going to show you from now on will work on both WPA and WPA2. Now, both of these encryptions came after WEP, and they were designed to address the weaknesses in it. Therefore, both of them are much more secure, and cracking them is more challenging. So, before we start talking about how to crack them, I want to cover a feature that, if enabled and misconfigured, can be exploited to recover the key without having to crack the actual encryption. The feature is called WPS. It allows devices to connect to the network easily without having to enter the key for the network. So it was designed to simplify the process of connecting printers and such devices. You can actually see a WPS button on most wireless enabled printers. If this button is pressed and then you press the WPS button on the router, you'll notice that the printer will connect to the router without you having to enter the key. This way, the authentication is done using an 8-digit PIN. So you can think of this as a password made up of only numbers, and the length of this password is only 8. So this actually gives us a relatively small list of possible passwords, and we can try all of these possible passwords within a relatively short time. Once we get this PIN, it can be used to recover the actual WPA or WPA2 key. So as you can see, with this method, we are not exploiting WPA or WPA2. We are actually exploiting a feature that can be enabled on these encryptions. So for this to work, first of all, we need WPS to be enabled on the network because it can be disabled. Also, it needs to be misconfigured. So it needs to be configured to use a normal PIN authentication and not a push button authentication. If push button authentication is used, then the router will refuse any pins that we try unless the WPS button is pressed on the router. Therefore, the method will not work if push button or PBC is enabled. So in most modern routers, PBC comes enabled by default or WPS will be disabled by default. So this method might not work. But because WPA and WPA2 are so secure and so challenging, it is always a good idea to check if WPS is enabled and try the method that I'm going to show you to crack the network. If it fails, then you can try the other methods that I'm going to show you after the next lecture. Okay, now that we know what WPS is and how it can be used to recover the password for WPA and WPA2 networks, let's see how to do that in practice. So, right here I have my Kali machine. I've already enabled monitor mode on my wireless adapter on Mon 0. Now usually we use AeroDumpNG to see all the networks around us. But right now we want to see the networks that have WPS enabled, but because like I said, it's just a feature and people can turn this feature off. So first of all, I'm going to use a tool called Wash to display all the networks around me that have WPS enabled. So we're going to do wash --interface and give it my interface in monitor mode, which is Mon 0. So all we're doing is wash is the name of the tool, interface to give it the interface, and Mon 0 is my wireless adapter in monitor mode. If I hit enter now, you'll see it'll list my network straight away. Now I pressed Ctrl C to cancel this, similar to AeroDumpNG, because it'll keep running unless you cancel it. And you can see this is my target network. It's called test AP. It's giving us the vendor of the hardware used in this network, in this access point. The LCK tell us whether WPS is locked or not, because sometimes WPS locks after a number of failed attempts. So right now this says no, which means that we can actually go ahead and try to guess the pin. It's giving us the version of WPS. It's using version 1. The signal strength is in here, the channel, and the BSS ID. Now I explained the meaning of all of these things before in my AeroDump-NG lecture, so I'm not going to talk about them now. If you forgot the meaning of any of these terms, please go back to the AeroDump-NG lecture. Now this network actually uses WPA2, so just to confirm this to you, if I go here to my host machine and just try to connect to it, you'll see that it's telling me that this uses a WPA2 password. But like I said, we don't care if it's WPA or WPA2 because we're going to be exploiting a feature in these encryptions, which is the WPS feature. So now that we know our target network uses WPS, there is a good chance that this attack will work against it. The only reason it might fail is if the target uses PBC or push button authentication. Like I said, if the target uses PBC, then it will refuse all the pins unless the button is pressed on the router, and therefore this attack will fail. The only way to know is to literally try this attack and see if it works. So I'm going to copy the MAC address of this network or the BSS ID. And the first thing that I'm going to do, similar to what we did with WEP, I'm going to associate with the target network using a fake authentication attack. So basically I'll be saying, I want to communicate with you, please don't ignore me, so that when I run the attack, the network will start accepting the pins and not ignore me. So to associate, we're going to use the exact same command that we used when we did it with WEP. So we're going to use a replay ng. We're going to tell it I want to run a fake authentication attack. We're going to give it the delay. So this is the time to wait between association attempts. Previously we set it to 0 and we had to do this manually every now and then. Right now I'm going to set it to 30 so that we associate with the target network every 30 seconds. Then I'm going to do -A to give it the MAC address of my target, and -H to give it the MAC address of my wireless adapter in monitor mode, and we've seen that we can get this by doing ifconfig and copy it from here. We said it's the first 12 digits, and I'll just replace the minus with the colon. And finally, I'm going to give it the name of my wireless adapter in monitor mode, which is mon0. So I explained this in details before. That's why I did it quickly. If you don't remember how I did this, please go back to the fake authentication attack lecture. So the command is ready now, but I'm not going to execute it. I'm going to go down to the bottom terminal and run Reaver, which is the program that will brute force the pin for me, and only then I will associate with the target, because otherwise a replay ng will fail to associate with my network. So I'm going to move to this terminal right here. I'm going to clear the screen and we're going to run Reaver, which is the program that's going to brute force the pin. So it's going to try every possible pin until it gets the right pin. Once it has the right pin, it'll use it to compute the actual WPA key. So using Reaver is very simple. It's very similar to everything we've been doing so far. So first of all, we have to type the program name, which is Reaver. Then I'm going to do --BSSID to give it the MAC address of my target network. So I'm just going to paste it. Then I'm going to do --channel and give it the channel of the target network, which is 1. Then we're going to do --interface and give it my wireless adapter in monitor mode, which is mon0. So a very simple command. We're using Reaver. This is the name of the program that will do the brute forcing for us and give us the key. We're giving it the BSS ID, the MAC address of my target. We're doing --channel to give it the channel that my target is running on. and we're doing dash dash interface to give it the name of my wireless adapter in monitor mode. I'm also gonna add two more options. I'm gonna add dash VVV to show us as much information as possible. This is really helpful. If it fails or things go wrong, we'll be able to know what's happening, why things are going wrong. And I'm also gonna do dash dash no associate to tell Reaver not to associate with the target network because we're already manually doing that in here. So Reaver can automatically do this step right here for you, but I've seen that it fails a lot. Therefore, it's actually better to do it ourselves manually here and then tell Reaver not to associate. So now I'm gonna hit enter to get Reaver to work. And I'm gonna go up to the top terminal and I'm gonna hit enter to associate with the target network, telling it please don't ignore us, so that Reaver at the bottom here can brute force the pin and try every possible pin until we get the correct pin, which we'll use to get the password. And as you can see right now, Reaver is trying the pin 1, 2, 3, 4, 5, 6, 7. And perfect. You can see the pin was actually 1, 2, 3, 4, 5, 6, 7, 0. So it's a simple pin. It actually came with this pin. So I didn't manually set this pin. My router came from the factory with WPS enabled with this pin. So like I said, this still works, but again, not against all routers. From that, it was able to discover the WPA key, which is UAU RWSXR, and the name of the router is test AP. So I can literally go ahead and connect with this password and I'll be able to connect to the network and see and decrypt all of the packets sent in the air. Now, if WPS is disabled on your target network, or if it's enabled but configured to use push button or PBC, then the method that I showed you in the previous lecture will not work. Therefore, you will have to go and crack the actual WPA or WPA2 encryption. And like I said, when these encryptions were designed, the developers knew about the weaknesses in WEP and they made sure that they properly fixed these weaknesses. They actually did a pretty good job at this. Therefore, we cannot use the same method used in WEP to crack WPA and WPA2. So in WPA2, the keys are unique, they're temporary, they're much longer than what they were in WEP. Therefore, the packets sent in the air contain no information that is useful for us. So it doesn't matter, even if we capture 1 million packets, we can't use them to crack the key. The only packets that contain useful information are the handshake packets. These are 4 packets transferred between a client and the router when the client connects to the network. So, in this lecture, I'm going to show you how to capture these packets, and in the next lectures, we'll see how to use them to crack the WPA or WPA2 key. First of all, as usual, you'd want to run aerodump-ng against all the networks around you. I've already done that, and as you can see, this is my target right here. It's using WPA2, and this is the MAC address. I'm going to copy it. And the first thing we'll do is just run aerodump-ng on this network and store the data in a file, exactly the same way that we used to do it with WEP. So we're just going to do aerodump-ng --bssid and give it the BSSID of my target, --channel, and give it the channel of my target, which is 1, --write, to specify a file name to store all the data that we're going to capture in. And let's call this WPA handshake, because we're going to capture the handshake. And finally, we're going to give it my wireless adapter in monitor mode, which is mon0. So very simple command. We've done this multiple times by now. We're using aerodump-ng. We're giving it the MAC address of my target after the BSSID. I'm giving it --channel to specify the channel of my target. I'm using --right to store all the data in a file. This file will contain everything that we capture. So if we capture the handshake, it will be in this file. And finally, I'm giving it the name of my wireless adapter in monitor mode. So now I'm gonna hit enter. And as you can see, AeroDump-ng is working against my target network. And right now, all we have to do is literally sit down and wait for the handshake to be captured. Like I said, the handshake is sent when a client connects to the network. So we'll literally have to sit down and wait until a new client connects to the network. Once a new client connects, we will capture the handshake, and you will see in here AeroDump telling us that the handshake has been captured. Alternatively, we can use something that we learned before, which is a deauthentication attack. We know using that attack, we can disconnect a client from the network. So we can do this for a very short period of time. We can disconnect this client from the network. He will automatically connect once we stop the attack. Therefore, when he automatically connects, the handshake will be sent in the air and we will be able to capture it. This way, we will not have to sit down and wait for someone to voluntarily connect to the network. So, we've seen how to do this before, and it's going to be exactly the same command as we did it before. We used areplay-ng, we did --deauth, then we specified a really large number of packets to keep the client disconnected for a long period of time. This time I'm going to set this to 4 to only send 4 deauthentication packets. This way, my client will be disconnected for a very short period of time. They won't even feel that they got disconnected, but this is enough for the handshake to be sent because they will be disconnected, they will automatically connect, and when they do that, we will capture the handshake. Now, the next argument we want to set is the MAC address of my target. So we're going to do -a followed by the MAC address of my target. Then we're going to do -c followed by the MAC address of the client that we want to disconnect. So it's this client right here. I'm going to copy, paste it here, and finally we're going to give it the name of my wireless adapter in monitor mode, which is mon0. And we are done. Again, I've spent a full lecture on this command explaining what a deauthentication attack is, so if it's a bit confusing, please go back and revise that lecture. Basically, all we're doing is we're using areplay-ng to run a deauthentication attack to disconnect this device for a very short period of time. That's why I'm setting this to only number 4. Then I'm using -a to specify the MAC address of my target, -c to specify the MAC address of the client connected to this network, and then I'm giving it my wireless adapter in monitor mode. Now I'm going to hit enter and keep an eye on this side right here. You'll see the handshake will be captured in here. So we're going to hit enter. The authentication packets are being sent. And perfect. As you can see, once the client connected again, we received the handshake. So now we can quit AeroDump-ng, so Control-C, because we have the handshake now. It is stored in the file that we set after the right option, which is called WPA handshake. And in the next lecture, I'll show you how this handshake can be used to get the key for the network. From the previous lectures, we learned that when it comes to WPA and WPA2, the only packets that contain some information that can help us with cracking the key are the handshake packets. And in the last lecture, we learned how to capture the handshake and store it in a file. Now, the handshake does not contain any information that can help us to recover or recalculate the WPA key. The information in it can only be used to check whether a password is valid or not. Therefore, what we're going to do is to create a word list, which is basically a big text file that contains a large number of passwords. Then go through this file, go through the passwords one by one, and use them with the handshake in order to check whether this password is valid or not. You can actually download ready word lists from the internet. But in this lecture, I want to teach you how to create your own word list. And in the next lecture, I'm going to explain to you how the word list and the handshake are used in order to recover the password. And we'll see how to do that in practice. So in this lecture, we're going to learn how you create your own word list using a tool called Crunch. This is a really handy skill to have under your belt if you want to be a penetration tester, because you're going to face a lot of scenarios where a word list attack can become very handy. So using the tool is very simple. All you have to do is just put the name of the tool, and then you specify the minimum number of characters for the passwords to be generated. Then we're going to specify the maximum number of characters for the password. Then you specify the characters that you want to generate passwords from. For example, you can put all lowercase characters, all uppercase, you can put numbers, digits, or you can just specify a smaller number to make the word list smaller. You can also use the option T, which is an optional, to give a pattern. So for example, let's say that you were looking at the person while they were typing their password, and you've seen that the password will start with an A. So you can tell Crunch that the password will start with an A, and then give me all possible combination of passwords that start with an A. And after that, we use the -O option to specify the file name where the passwords are going to be stored. So we have a small little example here that will generate a list of passwords that start from 6 characters to 8 characters and contain these characters right here. So it's going to create combinations of 1, 2, 3, ABC, and the $sign. And it's going to store it in a file called word list. And these passwords are going to start with an A and end with a B. And it will generate passwords based on all possible combinations between the A and the B. So all of the generated passwords will always start with A and end with B. So let's have an example of the tool. Now the tool actually have a lot of options other than what we've seen so far. So if you just type in man crunch, you'll see all the options that you can set, and you'll see detailed description about all of these options. So it's actually really good. You can go ahead and spend some time to get familiar with the tool. Now I'm going to show you the example, and based on the example, you'll be able to run all of these commands. But if you want to run or create some advanced word lists, then I highly recommend that you go over this. One of the really cool options that I want to highlight is the -P option. The -P option tells Crunch to generate passwords that don't have repeating characters. For example, when you specify all lowercase characters, you specify A, B, C, D, it will start by generating passwords made of A, and then A, B, and all of that. So when you do this, Crunch will actually ignore these type of passwords, and it will only create passwords that don't have any repeating characters. And that will reduce the size of the word list from the number of characters to the power of the length to the number of characters factorial. If you scroll down, you'll actually see more examples of commands and the type of word lists that will be created. So again, you can have a look on these and get yourself familiar with. Once you're done looking at the man, you can just press Q and you'll be out of it. And we're going to run our command here. So we're going to use Crunch. And I want to generate passwords of minimum of 6 characters and maximum of 8 characters. And I want them to contain combinations of A, B, C. And let's say the digits 1, 2. Now in here you can actually keep listing things. You can list characters, you can list uppercase characters, or even symbols if you wanted to. Once you're done with listing the characters, we're going to specify the file to save it to, and we're going to save it in a file called test.txt. So the command is very simple. It's crunch, minimum length of the password, the maximum length of the password, followed by the characters that we want to use to generate passwords from, and then O to the file that the passwords are going to be stored in. I'm going to hit enter. And as you can see now, it's telling us that it generated 448,000 passwords approximately, and they're all stored in a file called test.txt now. The size of the file is 4 megabytes. And now I can open this file by doing cat test.txt. And as you can see now, we can see all the passwords that have been generated. I'm going to Control-C out of it because it's a huge file. And as you can see, it actually contains all possible combinations of ABC12. I also want to show you an example of using the -t option. So I'm going to set this to only 6 to 6, so it's only 6 characters. And we're going to use the -t option, which is the pattern option. And I'm going to tell it that I want the password to always start with an A. And then I want you to fill all possible combinations of characters between the A and the B. So I want passwords that start with an A and end with a B. And in the middle, at the @ sign, you can fill all possible combinations of ABC12. Gonna hit enter. As you can see now, the number of passwords is much less. It's only 625 passwords because I've narrowed down the possibilities of passwords. Again, if I do cat test.txt, you'll see that I have all the passwords right here. So this is it. Tool is really useful, can be used in many scenarios. I highly recommend that you spend some time with it and also have a look on some of the existing word lists out there on the internet. Now, from the previous lectures, we learned in order to crack WPA or WPA2, we need to first capture the handshake and second have a word list which contains a number of passwords that we're going to try, and hopefully one of them will be the password for the target network. So right now I have both of these components and we are ready to go and crack the password. To do this, aircrack-ng is going to unpack the handshake and extract the useful information. The MIC right here, or the message integrity code, is what's used by the access point to verify whether a password is correct or not. So it's going to separate this and put it to the side, and then it's going to use all of the other information right here combined with the first password from the word list to generate an MIC, another message integrity code. And then it's going to compare this MIC to the one that's already in the handshake. If the MIC generated using this information plus the first password is the same, then the password used to generate this MIC is the password for the network. Otherwise, this password is wrong and it'll move to the next password. Again, it'll do the same. It'll use all of this information combined with this password, generate a new MIC, compare this new MIC to the one that's already in the handshake. If it's correct, then this is the password. If it's not, then it's going to move on to the next password. And it'll keep doing this through all of the passwords in my word list. If any of them generates the right MIC, then this is the password for the network. Otherwise, we won't be able to get the password. That's why the success of this attack really depends on your word list. So, let's see how to do this in practice. Right now, I have my word list right here. It's called test.txt. And I've actually manually added my password to the end of the list right here, just so that when I run the word list against the handshake, I will actually find the password, because the word list did not contain my password by default. I also have the handshake file right here, as you can see, and all of this is in my home directory, which is my root directory. So if I do ls in here, you'll see I have the word list and the handshake file. So we're ready to run aircrack-ng. So we're going to type the name of the program as usual, followed by the name of my capture file, which is WPA handshake01.cap. So far it's identical to the way that we used to use it with WEP. The only difference right now, because this is a WPA2 network, we have to specify a word list with the -w option. And the name of my word list is test.txt. So very simple. Aircrack is the name of my program. WPA handshake01.cap is the name of the file that contained my handshake, and I'm using -w to specify my word list file. I'm gonna hit enter. And as you can see now, aircrack-ng is running through the word list, testing each word in the word list one by one, as shown in this diagram, calculating an MIC based on this information and the word list, and then if the MIC is correct, it's going to tell me that this is the password. Now, the speed of this depends on your processor and the size of your word list file. So if you have a huge file, obviously it will take you longer time. There are also online services that you can try where you upload the handshake, and they have huge word lists and they have supercomputers to run through these word lists and try to give you the password. Unfortunately, I can't share their links with you, but you can easily find them on Google if you search for them. And perfect, as you can see, we managed to find the key. It's telling us the key is found, and this is the key to the network. And this is the correct key because, as you know, this is the same key that we got when we exploited the WPS feature. So now we can go ahead and connect to the network, and we'll be able to run all of the cool stuff that I'm going to teach you in the post-connection attack section. Now, this is the only practical way known so far to crack WPA and WPA2 keys. There are methods to speed up this process, so you can use the GPU for cracking because it's much faster than the CPU. That's if you have a GPU. You can also use rainbow tables. You can also pipe the word list as it's being created in Crunch to aircrack-ng. This way you can create bigger word lists without using any storage on your computer. There are also methods so that you can pause your cracking process and then come back after a while without losing your progress. But the main idea is the same. The only way right now to crack WPA and WPA2 is through a word list attack. You can use social engineering, however, to get the password using an evil twin attack where you trick one of the users to give you the password. This is actually all covered in my advanced network hacking course. The cracking using the GPU, piping Crunch to aircrack-ng, getting the password using an evil twin attack, and much more advanced network hacking techniques. If you're interested in that, then I highly recommend you have a look on my advanced network hacking course. Check out the bonus lecture of this course, the last lecture of this course. It contains links to all of my other courses and a comparison between them.